Now, when we talk about processor width, this is the actual size of the highway. That's the analogy I've always liked to use. I used it in the motherboard lesson, and I'll use it again here now. Okay, it's the actual width. It's like the number of wires, the amount of data that can travel in parallel with other data. Now, I will tell you that there are two common widths that are available in today's processors. We have 32-bit processors and we have 64-bit processors. And one thing I want to point out to you real fast here, this is a quick little side note, a little bit of a history lesson here. On the left here we have 32-bit, and next to it it says x86. And then on the right we have 64-bit, and it says x64. Now this is a question I get asked all the time. It makes sense why x64 means 64-bit, right? But why the heck do we say x86 to represent 32-bit? People have racked their brains trying to do mathematical formulas, all kinds of stuff, trying to figure out how does the 32 and 86, how do they relate to one another? It just doesn't make sense. Well, the reason that we refer to our 32-bit processors as x86 processors has to do with, if we go way back to some of the original Intel processors. Okay, I mean, technically, if you go back way back, we can go even before the 86 brand of processors. Okay, but if you go back to the 80s and the 90s, you may recall that there were processors called the 286 processor and the 386 processor and the 486 processor. Okay, so depending on how old you are and how long you've been familiar with computing technology terms, I mean, even as an end user, right, just out buying a computer. And I will tell you, back in the days of like the 286, I was not working in this business professionally. I was just an end user. I was buying a computer. Okay, and so that's where the 86 comes from. The X is like the variable, right? x86, 286, 386, 486. Matter of fact, the processor that came after the 486 was something called the Pentium. And a lot of people are like, well, where'd that name come from? Hey, maybe that's a fun name to say, but what does the word Pentium actually mean? I mean, why did they name it that? Well, because the next processor was going to be the 586 processor. But it got to the point that from a marketing perspective, it wasn't a very attractive name. So they came up with the name Pentium. Penta for 5. Okay, so we have the Pentium processor. How about that, huh? So that's where the x86 comes from, is the older 32-bit processors were named something 86. Now, let's reel it back into the technical specs. One thing you should know is that when you are working with an x86 or a 32-bit processor, the most amount of RAM that processor can associate with and can process and address is 4 gigs of memory. Okay, that's it. You were maxed out at 4 gig. Now, for many years, that was a huge number. I mean, back in the day, we used to talk about how many kilobytes of RAM. And then it was exciting when we got to how many megabytes of RAM. But considering, a gigabyte of RAM is 1,000 megabytes, and, we were looking at systems that had 1 megabyte of RAM, 2 megabytes of RAM, 4 megabytes of RAM, getting up to 4,000 megabytes of RAM, which is 4 gigabytes of RAM. Well, that was going to be way out into the future somewhere. Well, not so much, because we hit that quite a few years back. I'd say, probably about 10 years ago. We were even further back if you really want to talk about mega systems. But I would say a comfortable 10 years ago, we were already, commonplace. Even regular PC users, especially gamers, they were looking to exceed past that 4 gigabyte of RAM maximum. And so that's where we had the need to move to the 64-bit processors, which can actually address 16 exabytes of RAM. That's right, you heard me, exabytes. Now, if you're not familiar with all of the different terminology, and we'll get to this in a later lesson, but I can tell you that, there's 8 bits in a byte. Okay, so each piece of data, right, every 1 or 0 is a bit. There's 8 of those that make up a byte. A kilobyte is 1,000 bytes. 1,000 kilobytes is a megabyte. Okay, so we could say 1,000,000 bytes is a megabyte. Now, by the way, it's not actually 1,000. It's technically 1,024. We just use 1,000 to keep it kind of simple to think about. But 1,000 megabytes is then a gigabyte. Now, those are numbers that most people are pretty familiar with. But when we go up from gigabytes, there's one more that people are very familiar with in today's world, and that is the terabyte. Right? 1,000 gigabytes is a terabyte. And that's because terabyte hard drives are very common right now. But if we go up from the terabyte, 1,000 terabytes is not an exabyte. It's actually a petabyte. 1,000 petabytes is then finally an exabyte. Okay, so when you want to talk about 16 exabytes of RAM, we once again are in a day and age where we're looking at that being well out into the future. But don't get too excited because, as we've seen with technology in the past, the future gets here a lot faster than we expect it to. All right, so it looks like it's going to be way out in the future, but heck, I might be talking to you 10 years from now saying that we're at that 16 exabyte maximum and we need to go to something else. Who knows?